This might sound crazy, but some scientists think that we can reverse climate change by growing seaweed. They argue that if we can build massive seaweed farms, grow tons of the stuff, and then bury it, it could pull enough carbon dioxide from the atmosphere to slow the pace of climate change. And since governments around the world are clearly delaying climate action as much as possible,
the green energy scam,
it could actually make a difference in keeping our planet's warming below the Paris Agreement threshold of 2 degrees C. It sounds almost too simple, and that's because it might be. But then why do some seriously smart people think it's a good idea to grow all the seaweed in the first place? Where would we even put it all? And could it cause more damage than it's worth? Let's get into it. Before we dive into the details of growing all this seaweed, why are scientists even considering the idea? It's no secret that our addiction to fossil fuels is increasing the carbon dioxide levels in our atmosphere, warming the planet and destabilizing our climate. And while some progress has been made to fix this, the levels continue to rise every year. So rather than waiting for governments to act on this or even believe it exists, some scientists have argued we need to begin carbon dioxide removal, or CDR. This can take on a lot of different forms, with some being artificial, like giant fans scrubbing CO2 directly from the air, but others are more nature-based. These ideas use plants to remove the CO2, like fertilizing the ocean to grow more plankton, planting 1 billion trees, or growing tons of macroalgae, also known as seaweed. Like all other plants in the ocean, seaweed uses dissolved carbon dioxide to photosynthesize and grow. And as it consumes dissolved CO2 to grow, the amount of CO2 in the ocean goes down, allowing the seawater to dissolve more from the air. So if we grow billions of tons of seaweed and store that carbon somewhere safe, we could, theoretically, remove billions of tons of CO2 from the air. But why seaweed? Also, if you're liking these types of videos, go ahead and click that subscribe button. It goes a long way to support the channel and climate science on YouTube. Seaweed has been a popular candidate for CDR for a couple of good reasons. First of all, seaweed grows insanely fast, with some species of kelp growing as fast as 2 feet per day. And while they may not look super impressive from the surface, this rapid growth, combined with their range of habitats, means that every year seaweed pulls almost as much CO2 from the atmosphere as the Amazon rainforest. Also, a lot of the seaweed carbon gets stored or sequestered naturally, keeping the carbon from going back into the air. When seaweed dies, some of it will sink to the bottom of the ocean as detritus. This eventually breaks down into sediment on the ocean floor, locking the seaweed's carbon underwater. Some of this can stay down here for thousands to millions of years, keeping it from getting back into the air where it can go back to warming the planet. Seaweed also creates another form of carbon in seawater known as dissolved organic carbon, or DOC. These are things like the slime on the seaweed surface, liquids in their cells, and all sorts of organic goop and gunk that dissolve into the ocean. Some of this DOC is super short-lived, like sugars that get eaten and respired by bacteria in only a couple of days, but a portion of it sticks around longer. This extra tough recalcitrant DOC, or RDOC, makes up anywhere from 5 to 56% of the total seaweed DOC, depending on the species, and it can stick around in the ocean for thousands of years. So seaweed actually have 2 pathways it uses to take carbon from the air and store it underwater for millennia. This is why some scientists want to scale up seaweed farms, accelerating these natural carbon sequestering processes to clean up our mess. But what would this even look like? Seaweed farming is already a massive industry, as I'm sure all you sushi and miso soup enjoyers can attest to. Most of the seaweed comes from China and Indonesia, with other Asian and coastal countries contributing to the global harvest. The seaweed is typically grown on ropes known as long lines that sit several feet below the ocean surface. Here they absorb nutrients, pull CO2 from the water, and are harvested for use in cooking, cosmetics, biomaterials, and pharmaceuticals. And seaweed farming also provides a lot of ecosystem services, like removing toxic metals and excess fertilizers from the water where it's grown. So basically, we would just need to scale up this system of growing seaweed and dedicate all of it to carbon sequestration. But just how big would it need to get to make a dent in our carbon emissions? Time to bust out the calculator. If we use kelp as a model seaweed, some sources report being able to harvest 13.1 kilograms of dry weight seaweed per square meter of nutrient-enriched ocean. Kelp is around 30% carbon on average, meaning that we could pull a maximum of 3.9 kilograms of carbon out of the seawater for every square meter of kelp farm. Our global fossil fuel carbon emissions for 2025 were a staggering 10.4 gigatons, or roughly 10,400 billion kilograms. So if we can optimistically remove 3.9 kilograms of carbon per square meter of ocean with kelp, we would need to farm kelp over 2.7 million square kilometers of the ocean. This is an area of water a little bit larger than the entire Mediterranean Sea, So certainly no easy task, but physically and technically possible. With proper fertilization, a study found that we could potentially grow seaweed over 48 million square kilometers of the ocean, far more than the 2.7 million that we would need using our calculations. And unlike land-based CDR ideas, there's really no shortage of ocean area to use for such a project. But the question then becomes, where are we going to put all this seaweed? In its natural setting, seaweed is constantly pulling carbon from the surface down into deep ocean waters. It's really quite efficient at this, with some estimates stating that it can sequester up to 268 million tons of carbon every year, or just about 2% of our fossil fuel emissions. So could we just dump a bunch of extra seaweed down there too, speeding up this natural process? Well, yes, but realistically, this would seriously disrupt any deep sea ecosystems unfortunate enough to be underneath our seaweed farms. Dumping millions of tons of seaweed would not only smother everything at the seafloor, but would also cause severe hypoxia in the deep waters. You see, as the seaweed decomposes, the aerobic bacteria eating it will consume oxygen in the process, depleting the deep waters of oxygen wherever the seaweed is dumped. So maybe dumping it all underwater isn't the best idea, but maybe it could be buried somewhere on land instead. But then we would just have a landfill full of soggy, rotting seaweed that's decomposing and releasing CO2 and methane back into the atmosphere, undoing all our hard work. So in order to make the seaweed carbon more stable, it would have to be converted into biochar. To do this, the seaweed would first be heated in an airtight environment, turning it into a type of charcoal, making it far more chemically stable than raw seaweed. This biochar could then be mixed into soils or buried in geologic reservoirs for carbon storage that lasts millennia or longer. This would cause a lot less environmental damage than dumping it at sea, and could even be a beneficial nutrient additive for farmland. So it's settled. We grow billions of tons of seaweed, drag it all back to land, toss it all in a stadium-sized furnace, and scatter the charcoal across the earth. Climate change solved. Right? Clearly, there is some potential to the CDR idea, but also a lot of logistical drawbacks and concerns. On the pro side, seaweed is relatively easy and quick to grow, and has the potential to store carbon away for millennia or longer. There's plenty of ocean space available for it, unlike with land-based solutions, so it could be scaled to levels comparable to our CO2 emissions. Cost-wise, it's one of the cheaper CDR strategies, with estimates putting it around $100 per ton of CO2 removed from the air. It can also be grown in strategic locations, such as areas with lots of fertilizer runoff, utilizing those nutrients and preventing them from causing toxic algae blooms in deoxygenated waters. Lastly, a small fraction of the seaweed could be set aside for food, cosmetics, or pharmaceuticals, which wouldn't help reduce carbon emissions, but could help lower the cost of the seaweed project. However, on the con side, this amount of seaweed aquaculture would undoubtedly disrupt every ecosystem where it's growing, which could harm biodiversity, important fisheries, or even the deep sea, as some seaweed will inevitably find its way down there. The nutrient demand of all this seaweed is also a concern. As it sucks up all the nitrate, phosphate, and iron from the waters it's grown in, other ecosystems downstream of the farm will experience a drop in nutrients as well. This is known as nutrient robbing, and while it could be solved by heavily fertilizing the seaweed, this will both raise costs and produce more greenhouse gases through the production of fertilizers. Dragging all this seaweed to land and charring it also increases the costs and emissions of such a project, and sinking it at sea is internationally forbidden by the London Protocol, which outlaws dumping in the global oceans. These are by no means the only pros and cons associated with this CDR strategy, but they certainly paint a picture of how complicated something like this could be. So, as you can probably tell by now, our solution to climate change isn't as simple as just growing tons of seaweed. If it were, we'd probably be doing it by now. Of course, the real solution to climate change is obvious. Stop burning fossil fuels and stop destroying our natural carbon sinks. However, as governments around the world continue to delay or deny a phase out of fossil fuels and a sustainable future, more experimental ideas may be necessary to buy us more time. As far as CDR ideas go, seaweed aquaculture is one of the cheaper and more practical ones, which is why it's already attracted hundreds of millions in investments. But if this idea is really going to take off, we need all eyes on it to make sure it's being conducted responsibly. We will need scientists to observe the impact on surrounding ecosystems, and politicians who can pull the plug if the damage is out of control. We will need third-party monitoring, reporting, and verification, or MRV, to stop companies from lying about how much carbon they sequester. We will need to watch how biochar changes after burying it to make sure the carbon stays underground and out of the atmosphere. And, most importantly, we will need to drastically cut back on fossil fuels at the same time, and not use the seaweed farms as an excuse to keep burning coal. It would be a project of truly epic proportions, the likes of which this world has never seen. But with our climate on the line, it could be one of the best ways to lower CO2 levels in our atmosphere and reverse the pace of climate change. Thanks for sticking around to the end. As always, all the sources are linked down below. If you learned something from this, enjoyed this, or just want to see more climate science on YouTube, make sure to like, comment, and subscribe to support Planet Zero. I will see you next time.